Alright, here's question 3 on the Unit 2 review. It says write an explicit or recursive rule for the following sequence. Alright, so the explicit is really kind of, you could write this as the y equals mx plus b format. That's really what that's kind of like. The other one, however, is you have to find a pattern. So the first thing, and both of them you actually do. So we know that we can see that this is increasing by 6 every time. We also need to pay attention if this is increasing by 1. And it is. Think about if you were doing slope, it would be the change in y over the change in x, which would make it 6 over 1. So really my slope would be 6. So I just want to kind of show you that. Since we know that it is, we're going to go on. Alright, so in the recursive rule, you have a of n equals a of n minus 1, and then that is plus the difference. All right, and so here's what we're going to do. We've noticed that the d is 6, so a of n equals a with an n minus 1 like a subscript, and our pattern is 6, so we'll put plus 6. Now this is our recursive rule. However, we have to tell you what we're starting off at. So in this case, I'm going to say a of 1 equals 9. All right, so what that means is that n's equaling 1. If you notice, this n is now a 1, so that means n is 1. So when n is 1 here, and I'm going to go ahead and erase this so we don't see all this. So when n is 1, we're saying it equals 9, and it does. You can see that it equals 9 there. Now what happens is that we take n and we put a 2 in n spot. So I'm going to kind of do this so you can kind of see this. Alright, so watch how I do this. I'm going to take n and I'm going to put a little 2 in there now. And then a of, and it's going to be 2 minus 1 plus 6. And then what's 2 minus 1? Well, 2 minus 1 makes it a1 plus 6. And now really, a of 2 equals a of 1 plus 6. So a of 1, if you remember, is right here. It says it's 9. And that's this part right here. So we take 9 and we add 6 to it, and a of 2 will equal 15. And look, a of 2 equals 15. Alright? And now if you wanted to find a third number, you could put a 3 in for the n. And so a of 3 equals a, and then 3 minus 1, and then we'll add 6 to that. So you remember the little subscript, it's kind of like in a parentheses. That's really what this is. This is really more in the parentheses. Alright, so I'll put this around here so you can see this. So you do the parentheses first. So a of 3 equals, and 3 minus 1 is 2, so a2 plus 6. Now what was the value that we found for a2? Well, if you look over here, we found a of 2 equals 15, so we're going to put a 15 here. And then we're just going to add 6 to it, so a of 3 equals 21. Alright, and if you notice, look, a of 3 is 21. So really all we're doing, and I'm going to clean this up a little bit, is that we are taking the f of n value that you see here in this little column here, and we're adding 6 to it each time to that number. So whatever that is, we're going to add 6 to it, add 6 to that, add 6 to that. And that's how you do it. If we wanted to find a number that wasn't on the table, we could pick a number and kind of keep making the table till we get to that number. Alright, so that is how you do the recursive rule. So the actual recursive rule is the setup that we created. So I'm going to go back and I'm going to erase everything to show you what all that does. And this right here is actually, and I'm going to box it for you so you can see it. This here, if I can box it, this here is our rule. Okay? and these are supposed to be A's. I accidentally erased the top part. All right, now, so how do I do the other rule? Well, there's a couple of ways you could do it. There's mx plus b can be done like this. So we have a n. You can use mx plus b, and I'll do both of them. In fact, let's do mx plus b first. All right, so if you remember, this is my slope. That's my pattern, and this is my y-intercept when x equals 0. All right. So let's start off with the slope. The slope is the second y minus the first y, so it's 6. We're adding 6 every time. So my pattern, my y, my m is going to be 6x. The b represents when x is 0. Well, this is my x value, this is my y value. And so if you notice, I got 4, 3, 2, 1, and I'm going to put a 0 right here. I'm counting backwards. And if I'm going this direction, I'm adding 6. If you saw over here, see I'm adding 6. But if I go this way, that means I'm subtracting 6. So I'm going to take 9 minus 6, and I'm going to get 3. So my y-intercept will be 3. So here is the y equals mx plus b, or one of the explicit rules that we could use. And let's test this. We can actually test this, and I'm going to kind of clean this up again so that way we can see it better. All right, and so we're going to pick a number for n, which is also x. Remember, n and x are really basically the same thing here. This is x, this is y. And so if I pick 2, for example, put 2 in here, 2 times 6 is 12. 12 plus 3 is going to give me 15, so that works. If I put a 4 in there, 4 times 6 is 24. 24 plus 3 is 27. So see how it works?